Hi, let's try to understand one of the most important topic of C programming which is required in embedded systems, that is functions. What are the functions in C? How to use functions in C? What are the different types of functions in C? Now, first of all, be very clear what is a function all about. A function is basically a piece of code which needs to be repeated for some particular job, for some particular task. For example, this repetitive task may be printing something on LCD, sending something from the serial port, or there are many such use cases in embedded systems. Function basically is written to repeat a task. Many a times it also happens that we can only send only 8 bit of data to LCD at a time. So if you have to write down welcome, then you have to call that function 8 times or 10 times or things like that. Now, the problem that happens with when we start doing embedded systems without understanding the embedded C is we get confused when different functions come to us, and that's what we are going to get a clarity over here. So, as said, function is nothing but codes that needs to be repeated for some particular task. Now, there are primarily three different types of functions. One is a kind of function which doesn't accept any argument, which doesn't return any argument, and it just do some operation, it just performs something. Now, what is argument, what is return, everything we'll see. Second type is function with one or more argument, but it doesn't return anything. Third function is function that returns one argument, or it can also accept multiple arguments into it. Now, what I mean to say all by all these things is, as always, we will be much clear on programming. So let me tell you what is a function. Now here, because we have a display buffer or because we have a display, I can explain the function very well. So hash include stdio.h void main, and I'm just going to do some printing over here. Now, what is basically function? Let me tell you. For example, let's say I am going to print this line over here. Many a times what happens is I have to print this separator line. You have seen this. I print this separator lines many times because if I am doing a program like I have some variables and if I have to print them one after another. So let's say I have a variable int a and b, and a has got some value, b has got some value, and I have to print them. So this is something. But before printing, what I do is I need to mention this line like this. For example, see, printf, the value of a is equal to %d, new line. Now I add this thing here. Then printf, the value of b is %d, we'll also add it here, comma a, comma b, things like that. And lastly, the value of addition is %d, comma c. Let's take c variable here and let's do the addition here itself. Now look at it here. This line, why I'm taking this simple example is the reason is very simple. This line is doing wonders in our output, okay? Because of this line, my output is much more readable. So I may need to print this line every now and then as and when required. Same thing will happen in embedded domain also, depending upon the application that you may have in your hand. Point being, here we will be discussing our first function, and that is the function which doesn't accept anything from the main program and it doesn't return anything to the main program. Okay, so this function's data type. Now remember, whenever you are declaring or writing a function, the function syntax is like that always. So function data type, then function name, then arguments, then open the function, close the function, and then Here you write the last statement as return and arguments if any. So this function data type means what? If the function returns some value, then we write it down over here. Currently, I'm going to study a function which doesn't return anything. So its data type will be void. Let's give it a name. Let me call it print dummy. It is not accepting anything. So this bracket is also blank, or it can also be void. And then in this function, what I'm doing is I'm just writing this line, printf /n and something something and /n. That's it. Now remember, this function is not accepting anything, so this bracket is blank. This function is not returning anything. Therefore, the type of function is also void. If it returns something, if it returns, let's say, an int value or char value or float value, then the type of the function should become int or char or float. We'll see that in a moment. So first, let's see void print dummy. That's my function. So instead of writing this whole line here, what I'll do is I'll remove this and simply do print dummy and semicolon. Print dummy and semicolon. Print dummy and semicolon. That's about it. So this is a function which we just created. It doesn't accept anything. It doesn't return anything. It simply performs its own job and returns to the main program. So remember, the execution goes like this. Whenever this particular line is called upon, now to understand the differences, let's do this. Instead of dashes, let's make it asterisk or star symbol. Now what happens here, see, whenever this function is called, at that moment the code goes here, it executes that line, returns back to the next line. Again the function call, code goes here and comes back and so on. So although we can see print dummy is pasted 3 times, it doesn't mean that the code is pasted 3 times. Code is there only at one location, which is over here. So this is your code and this is where you call it. This is the very basic function definition. Now also remember, I have written this function before void main. Why? Because many compilers will not support if you write the function here. They will give you error. Now here about code blocks, I don't know. Let's run it. It worked. But many embedded compilers will give you an error when you write the function below main. In that case, what you need to do is, you can keep the function definition below main, but you have to declare it over here. Declare means nothing. Whatever is the name of function, whatever are its data type, write it down over here and give a semicolon. This is called as function definition and this is called as function. This is called as function definition and this is called as function declaration. So there are multiple things we are discussing in this video. First, how to declare a function, how to define a function, and then we have seen how to define a function which doesn't accept any value from the main code and doesn't return any value to the main code. In the next video, we'll see a different type of function. For now, I'll end this video here. Please rewatch the video if needed and just try this, making this kind of function in your program. Thank you for watching this video. Now that we have seen the function declaration and definition, now what I'll do is I will save the same program as function_2. Now this time what I'm going to do is I'm going to create a function. I'm going to create a function to print square of a number. Now let's see. Now for square of a number, I'll just take 2 integers, a and b. What we'll do is we'll scan a. So printf, please enter a number. Then print dummy, that will add that dummy line for us. Then scanf %d comma, ampersand a. So please enter a number. Then we scanned the number and we got our number into a. Now I have to write down a function which performs square of a number. Now when I have to write down a function to perform square of a number, then I need to pass the argument, or I need to pass this number a to that function, and I also need to take a number return from that function, which is the square value. Now for that sake, see, my function will be written like this. So I'll write it down over here. I will declare it over here. Now look at the declaration, how the declaration will be. Now I cannot write void my square. Let's say my name of the function is my square, and this is the kind of definition. But will this definition work? No, it will not work, because first thing, this function is going to accept this a value. A is what? Int. So you need to declare it inside it. How? Int, maybe a, maybe x, maybe b, it doesn't matter. Okay, you can write any name over here. Point is, if the function is going to accept an argument from the main program, you need to write it over here. So let's say it become int a. The function declaration became void my square int a. Now this is okay if the function is accepting a value and printing the result on its own. But I don't want to print the result in function. I want to return this square back to the main program. So the data type of return should be mentioned over here. So it becomes int my square int a. Why int a? Because I am going to pass an integer to it. Why int my square? Because my square is going to return a value which is going to have a data type int. Let's see how this function definition would be. So int my square int a. Definition is very simple. Actually, there is nothing into it. So return a into a. You can do that, or you can alternatively take another variable int x. X is equal to a into a, and then return it. Anything will do. We'll just keep it like this for simplicity. Now when a function returns a value, then it needs to be called like this. So b is equal to my square a. Because the programmer knows that this function is going to return a value, so it should always be returned, or it should always be called on the right hand side of assignment operator. Now let's try to print the square value. So printf square of %d is %d, comma a, comma b. Please look at the function carefully. Int my square int a. Why this int? Because it is going to return a value. Why this int? Because it is going to accept one argument from your program. Why it has been called on the right hand side of assignment operator? Because it is going to return something. If it isn't returning anything like print dummy, then you can directly call it like print dummy itself. But this is, however, going to return. Therefore, b is equal to my square, and here you pass the value a. I hope this is clear to you. Now let's run this code. Enter a number. So let me enter 9. Okay, and hit enter. Square of 9 is 81. You can see the result is printed, and this dummy is also printed. Now this print dummy is actually, however, here unnecessary, unwanted, but I'm just keeping it for the sake of understanding. So this is the second type of function we have seen in this video. Function which accepts an argument and function which returns an argument. Now let's say another function which accepts an argument but doesn't return an argument. In that case, the data type should be void. So what I can do is void print square. It will accept the variable. Remember, it is not needed to be kept a. You can very well keep it I. You can very well keep it j like that. So if it is j, then here your multiplication should be j by j. What I have written here is int I. Now the function definition will go like this. void print square, open and close bracket. Now this is not going to return anything, therefore the data type of function is void. Instead of returning, what I can do is I can do printf. Print result here. If you want, you can also call it print dummy from the function. So one function calling another function is also okay. Now let's do one thing. We'll have to take another variable here. Let's call it k. K is equal to I multiplied by I. Printf /n square of %d is %d. First value is I, second value is k. Remember, only I and k are accessible here. The variable a and b are local variable in main body. I will explain about local and global variables later on. But for now, just understand that a and b only accessible here. And here what we can access is I, and the one we create k. Now print square function will be executed like this. No need to return anything. Now, in that case, what I will do is, instead of calling these three lines, I will simply call print square and pass on the variable a into it. Let's try to run this code. Enter a number 7. Print result here, dummy, square of 7 is 49. So you have seen two different functions here in this program. One which can return a value, one which doesn't return a value. But instead of returning, it is printing the value here itself. How you write your function depends upon your particular requirement. There is no rule of thumb over there that you should write only this type of function or that type of function. It depends totally upon your usage. What I am doing here is I am just going to explain you all the type of function writing, and then we'll see the different examples for it. One more thing you have to remember, a function can accept multiple arguments, but it can only return one value. A C program will only return only one value in return statement. That's it for this program. Try it out. The function is called as function 2 here. You can see that in your code bank and try this out, or you may write it down as I have written here. Let's see in the next video what is the other one more type of function. Thank you for watching. Now let's see another one type of function which can accept multiple values. Okay. So let's save it as function _3. Always remember, in all the codes, all the programs, whenever you are going through it, the name of the function or name of the C file you can see in the video here, and then access it from the code library over there. Now hash include stdio.h void main, and now I want to print or create a function which will return or which will print the multiplication of number. So int a comma b, printf, enter two values /n, then scanf %d comma %a, that's scanning of the first variable, then I'll just keep it short, printf, enter other value, new line here also, scanf %d comma b. Now the function should accept these two values and return one value again. So it is going to return a value. So the data type of function will be int. Then the function name, it can be anything, let's say mul, because it is doing multiplication. And then here you will accept the two arguments that are going to come. So the two arguments that are going to come can be int p comma int q, and then semicolon. This is what? Function declaration. Let's define the function here. So int mul, int p comma int q, and the definition will go like this. So basically we just need to return P multiplied by Q. So a single line will also do. Let's take another variable, call it as result. And now let's write down result is equal to P multiplied by Q. And print F, new line. The product of %d into %d is equal to %d. A comma B comma result. So this is how you accept two values in C program. Remember, the order is important. Here P will get the value that you are passing first. That is, sorry, it should not be P into Q like that. Here it should be mul A comma B. So the value of A will be stored in variable P. The value of B will be stored in variable Q. These are just two arguments. A function may have multiple arguments also. So it may have 3, 4, 5, 6 or even just a single argument. In each case, you will have to accept those arguments like this. You have to write down different int declarations or float declaration, whatever type of variable you are passing. You have to write down that kind of declaration and you have to create a variable for it. So consider this as the blank spaces onto which this passed on values will be cached. So A will be cached in P, B will be cached in Q. The function, however, here is very simple. We are just returning the multiplication P and Q here and we are printing the result. Let's try to run this code. So enter two values. So let's say 45, enter other value, let's say 41. The product of 45 into 41 is equal to 1845. Getting it? So this is how you write a function which will accept multiple values and return a single value. Now, I'm going to give you some different problem exercises or problem statements to complete. So you have to just complete those problem statements on yourself. Okay. So write below programs by creating a function. So the first program I'm going to give you is create a function for factorial of a number. Scan a number and perform its factorial using functions. Okay. Then scan 6 numbers from user. Create a function called largest and create a function called smallest and try to find the largest and smallest using these two functions. What I mean to say by this is, I will be explaining it to you. Okay, just a moment. Function tasks. I'm just writing it here. You may or may not file this file. I want you to experiment this now. The tasks are very simple. So I'm not expecting that I write this task somewhere and then you access it. Okay, but still I'm saving this file. So the tasks are very simple. I'm also going to show you how I want it to be done. So create a function for factorial of a number. Let me show you what I meant by this. So empty file, save it as function underscore factorial. So I want it like this. So void main, then sorry, not void main, hash include stdio.h. Then you need to write down a function. So it returns int factorial. It accepts int. So int num. That's how your function definition should be. Then void main printf. In printf, what you will do is you will simply write down enter a number for factorial calculations. new line. Then you need to have int a comma b declared here. And then what you will do is scanf or scan this number %d comma ampersand a. Then what I want is b is equal to factorial of a and then printf factorial of %d is equal to %d, and it should be a comma b. Now your job is to write this body. Okay, so semicolon is not there when you define the function, so you have to write down the body here, which will accept this number and it will create its factorial. Another program, as I said, is something like that. Now I will also explain that, but in a very simple brief. So I'll not show void main or something like that. I'll just tell you like this. So void or int smallest, it accepts 6 values. So a1, int a2, int a3, int a4, int a5 and int a6. So this is how your function will be. You will scan 6 values and you will have to write down a body for it, which will return one int, which is the smallest among them. Now the same way there will be a function for largest. So int smallest is one function, then there will be int largest. Rest all remains like this. So other things will be same. So what you will do is hash include stdio.h. Then these two functions are defined over here. And what I can do is void main. Here int, let's call it a comma b comma c, d comma e comma f. Then here write a code to scan 6 numbers. You can use for loop also to do that. And now you also need largest and smallest, or the name are conflicting with function name. So just call it large and small. So after you write the code to scan the numbers, next code will be large is equal to largest, pass on the 6 numbers to it. So A, B, C, D, E, F, and small is equal to smallest. So I'm just giving you the body. You need to complete the code. Okay. Where those codes should be written, the code should be written over here. So this should be body of smallest. Remove this semicolon. This should be the body of largest. So that's how you need to write down these two functions. Try to do it completely on your own and tell me the output or show me the output. Okay. Please try it on your own only and then only proceed further to see the solutions. Thank you for watching this video. Hi. Now let's look at how we can write the bodies of these two functions. So one is for factorial and another one is for largest and smallest. So for factorial, almost half of the job is done over here, as you can see. All you need here, or all we need here is, I need, let's say, a factorial number, or let's call it int my fact is equal to 1. And then what we need is int I. And then what we do is, for I equal to 1, I less than num, or I less than num or equal to num, I plus plus. So this is what a for loop that we are creating to create or to generate factorial. So my fact is equal to my fact multiplied by I. Same logic is utilized. We are multiplying all the numbers from 1 up to that number itself with each other and creating a result in my fact. Last line should be here, return my fact, which consists of the number. Now this my fact will be returned and stored in the variable b, and then the variable b is going to print it. Let's see the output. Enter a number for factorial calculations. Let me enter 7. Factorial of 7 is 5040. Something is wrong, right? Let me check it again. Enter a number for factorial calculation. So let's say 4. 1 into 2 into 3 into 4. So it's 24. Okay. 24 is correct. Factorial of 5 is 120, correct? Yeah, correct. All is good. Factorial of 6 is 720 and so on. The number we had given was 7. 5040. Let's test it out. I was not so sure. So 1 into 2 into 3 into 4 into 5 into 6 into 7. It's 5040. Correct. So this is how you will solve the factorial. The next program that I had given you was largest and smallest. Again, the entire bodies were created for you. There was very less thing that you need to do. So here I need to scan 6 number first. So I'll just take integer I, and then what I'll do is printf, enter 6 numbers one by one. And then for I equal to 0, I less than 6, I plus plus. You can also use arrays here. In fact, if you have to use for loop, you will have to use arrays here. If you don't want to use arrays, then you may write down the scanf functions manually like that. So ampersand A, then B, C, D, E, F. B, C, D, E, F. Now the large is equal to large and small is equal to smallest. So let's print F. Largest number is %d, comma large, semicolon, and then the smallest number is small. Everything is same. Now we'll have to write down the body here. So we have got the 6 numbers. All we need to do is we need to find out which is the largest or which is the smallest. So starting with A1, let's make int small or int s, I'll call it. S is equal to 0. If, let's write it down now, how it is. So if s is less than a1, then I can write down if s is greater than a1, then s is equal to a1. If there is a single line in your if condition, it is okay if you don't give a curly bracket. Okay. So if s is greater than a1, s is equal to a1. If s is greater than a2, then s is equal to a2. If s is greater than a3, a is equal to a3. I know this logic may not work correctly because we are not checking it all with every number, but let's give it a try. We'll do the largest later on. First, let's try to find out the smallest. So here what will happen, s will be checked with a1. If it is less than a1, then it will be replaced. Or if s is 0 and a1 is 2, then it will come or it will become 2. If a2 is greater than 2, then only the replacement will happen. Otherwise, S will contain the smallest number. I believe this logic should work. We'll just have to give it a try. First of all, let's run it. So enter 6 numbers one by one. So 65, 98, 74, 31, 5, 69. The smallest number is 65. So the logic went wrong. If S is greater than A1, then only we are doing the replacement. If S is greater than, so here the replacement should have happened actually. This is A1, this is A2, this is A3, this is A4, this is A5. If S is greater than A5, then S should become A5. Okay. So S becomes 65 over here. Now it's second time if S is greater than A2. So 65 is greater than 98. Okay, I understood it. So you cannot check it for greater than. If S is greater than the next number, then there will be replacement. Okay, here there is no replacement, so it is as it is. So here S is greater than 74, no replacement. S greater than, here it should be replacement, so it should become 31. Okay, it should have worked, but I don't know why it didn't work. Let's try it when we make S is equal to 0 to begin with. 6 number one by one. So 35, 65, 92, 41, 3, 2. Okay. Nothing is happening after the first line. Small. Okay. My mistake. My very big mistake. So I need to call this function called smallest. Let's give it a try. So it won't work. Build and run. So 35, 68, 95, 451, 6, 312. Smallest number is 0. Okay, the replacement never actually happened. So we don't need S is equal to 0. Just initialize S with A1 or any number into the, or any number from them. So 65, 32, 253, 125, 68, 21. Smallest number is 21. It worked. The logic is correct. The mistake was there in my programming itself. In the same way, I will do largest. Now the only thing I need to do is I need to change this symbol. So if S is smaller than the number being compared, then we replace that into S. Let's do that. Large is equal to largest and print that also. Int S. So enter 6 numbers one by one. 65, 95, 89, 68, 31, 250. Largest number is 250, smallest number is 31. The program worked correctly. So that's how you will create your logics on the go and use the functions to write your program. I hope this will be understandable to you. So please just watch it once and then try it completely on your own later on. Thank you for watching this video.